today we will discuss about acids, bases and salts. Okay, first acids. The word acid came from the Latin. The word acid came from Latin name acid. Came from Latin name acidus. 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 Meaning sour or tart. Since the water solutions of acids have a sour taste or tart taste. Sour and tart is the same meaning, but the name only change. Lemon, grapefruit. Suppose we will eat lemon means the taste of the lemon is sour taste. Sour taste. Wait. Sour taste. Okay? And limes taste sour because they contain citric acid. In the lime, they have citric acid and ascorbic acid. In the two acids have vitamin C. Another common acid is vinegar. Which is sour liquid produced when a apple cider. Suppose we cut one apple. Cut one apple. The sound is this one. Okay. Grape juice or other plant juices. Ferment belonged. Wait. Okay. Beyond the formation of alcohol. Vinegar is a 5% water solution of acetic acid. Vinegar have 5% of water solution of acetic acid. So next, properties of acids. First, taste. Number one is taste. Acids are generally sour in taste. All acids have sour in taste. Sour taste is a property common to compounds classification of acids. Next, color change with indicators. Next, indicators indicators are substances that undergo a change of color with a chance of acidic, neutral, basic, medium. There are three types that are acidic, basic and medium. Acids change the color of indicators as given in the table. There are three types of indicator: litmus, methyl orange and phenolphthalein. Suppose we one blue litmus. We will do one. Suppose this is blue litmus. Push into that one glass. Okay, and in the next side, now and push in that paper. Push for two seconds only, and pull it. The color change blue to red. Okay, and methyl orange. Orange and yellow. Okay, we take yellow and pink color. Same thing. Okay, same thing. We push it for 2 seconds and pull it. Okay, and pull it. Phenolphthalein, deep pink and colorless. Suppose we push it for 2 seconds, deep pink color, and pull it, it will come colorless, like air. And next, corrosive action. The common corrosive action. The common man the man in street connects the term acid with an idea of corrosive burning liquid. This is because of two commonest acids, sulfuric and nitric acid. The two commonest acids are sulfuric acid and nitric acid are actually corrosive liquids. The sulfuric acid and nitric acid are corrosive liquids. Okay. Acids are generally not corrosive except mineral acids, H2SO4, HNO3 and HCl, etc. And most of them are solids like organic acids, oxalic acids, tartic acid and ascorbic acid and citric acid, etc. Next, some chemical reactions of acids. Some chemical reactions of acid. Action of acid. Metals which lie above hydrogen in the metal activity series already studied in the chapter. This is, don't see that one. Generally react with dilute acids to form their respective salt and hydrogen. Suppose we take one metal plus one acid A. It will give salt plus hydrogen. Okay, now guys, we mix metal plus acid. It will give salt plus hydrogen. And next, magnesium Mg plus H2Cl, hydrochloric acid. Okay, and it will give MgCl2. MgCl2 means magnesium chloride plus hydrogen. Next, zinc shortcut is Zn. Next, 2HCl. The two are same, but the two values. This is magnesium and this is zinc. Two values are only different. 2 HCl, and it will give ZnCl2 plus hydrogen. Next, iron plus sulfuric acid. It will give iron sulfate plus hydrogen. And this one is zinc chloride plus hydrogen, magnesium chloride, MgCl2. Fe plus H2SO4, and it will give HeCO4 plus H2. Okay. Next, very active, this is one A and this is B. And next, now B. Okay. Very active elements like potassium, sodium and calcium also react similarly but tend to explode when combining with acids. First, sodium plus dilute hydrochloric acid. It will give sodium chloride plus hydrogen. Okay. Next, nitric acid of various concentrations usually exhibits oxidizing property rather than acidic properties. Metals such as magnesium combine with extremely dilute 1% only nitric acid to liberate hydrogen. Okay, here is the magnesium nitric acid, magnesium nitrate plus hydrogen. Next page. Example and the solution. And here is one example. And this is the dilute H2SO4. H2SO4 means okay. And this is what this means dilute H2SO4, and it is a wolf bottle. And this bottle, wolf bottle, okay. And this layer, this water is granulated zinc, and will go gas here to here to here. It will come. And next, this is the hydrogen gas. This gas is the hydrogen gas. Action with basic oxides. Next, oxides that can add on hydroxyl ions to their molecules are called basic oxides. These oxides get neutralized when they react with acids. First example, basic oxide plus acid. It will give salt plus water. What means H2O. Or next, sodium oxide plus hydrochloric acid. It will give sodium chloride plus water. Na2O plus 2HCl. It will give 2 NaCl plus H2O. Next, lead oxide. We will remove O. It will get lead. O. Cake. PbO plus 2 HNO3. It will give Pb NO3 2 lead nitrate. NO3 2, and it will give us water, and it will add water, and some add water also. Next, copper oxide plus sulfuric acid. It will gives copper solvent plus water. Okay, you write copper oxide plus O plus sulfuric acid H2SO4, and it will give CuSO4. This is aquatic. AQ means aquatic, and this means liquid. Okay, plus water, liquid. Don't write liquid aquatic. It's necessary. This is not necessary. And next, action with basic hydrochloric acids. That is hydroxides. As action with basic hydroxides. Okay. Acids undergo neutralization with basic hydroxides to form salt and water. Okay. First, basic hydroxide plus acid. It will use salt plus water. This is the important one, and this is the okay. 2. potassium hydroxide plus carbonic acid. It will give potassium carbonate plus water. It is potassium hydroxide. It is carbonate hydroxide. Carbonate. Okay. 2KOH aquatic plus H2CO3. It will give Ka2CO3. I'll add plus here. Gives H2O. And next, okay. NaOH plus HO3PO4. It will give Na3PO4 plus 3H2O. Next, sodium hydroxide plus sulfuric acid. It will give ammonium sulfate plus water. 2NH4OH plus H2SO4. NH4 2SO4 plus 2H2O. Next, action with carbonates and hydrogen carbonates. Next, acids react with carbonates and hydrogen carbonates to form their respective salt, water and carbon dioxide. Carbon dioxide means CO2, water means H2O. Carbonate are bicarbonate plus acid. It will use salt plus water plus carbon dioxide. Na2CO3 plus 2HCl. It will give 2NaCl plus H2O plus CO2. Now, zinc carbonate plus sulfuric acid. It will give zinc sulfate plus water plus carbon dioxide. ZnCO3 plus H2SO4. It will give ZnSO4 plus H2O plus 2CO2. Next, discuss here illustration. No. And we discuss about with metal sulfates. And after bases, where are bases? Where are bases? Today I will discuss acids, and tomorrow I will discuss bases. Okay, and here some more problems are there here. Na2SO3 means sodium sulfate. 2HNO3. 2HNO3 means nitric acid. 2NaNO3 sodium nitrate. H2O water. SO2 sulfur dioxide. Na2SO3 plus 2HNO3 plus 2NaNO3 plus H2O plus SO2 means sulfur dioxide. Now ZnSO3 plus 2HNO3, it will give ZnNO3 twice aquatic plus H2O plus SO2. And here with metal sulfates. And here I will start here onwards. Magnesium sulfide plus hydrochloric acid 2HCl, and it will give MgCl2 plus H2S. Next one FeS means iron sulfide plus H2SO4 means sulfuric acid. It will give FeSO4, and it will give plus H2S. FeSO4 means iron sulfate. H2S means hydrochloric acids. These experimentally observed properties of acid and other solutions provide a definition for this class of compounds. An acid is a compound that dissolves in water to give a solution that does all the follows. First, conducts electricity. Taste source. Change the color of litmus from blue to red. Yes, correct. Reacts with active metals such as zinc, liberating hydrogen gas. It's also true. Next, reacts with carbonates releasing carbon dioxide. Yes, it's also true. Next, classification of acids. First, there are two types of 2 3 I think 4. Okay, first one, classification based on the source. On basis of source, acids can be classified into two groups. 1. Organic acids and 2. Mineral acids. First one, organic acids. Acids obtained from plants, mineral and animals are called organic acids. Acids obtained from plants material and animals, so that are called organic acid. Example, citric acid, oranges and lemons. Acetic acid, vinegar, and olive oil, and mineral acids. Acids obtained from minerals are called mineral acids or inorganic acid. They do not contain carbon. Example, H2SO4, HCl, HNO3. And next, classification based on pressure of oxygen. There are two types. They are oxyacid and hydroxides. First, oxyacids are those which contain oxygen in their composition. Examples: H2SO4, sulfuric acid; oxalic acid, H2C2O4; nitric acid, HNO3; acetic acid, CH3COO4. And next, hydroxides. Acids which contain hydrogen together with other elements are not oxygen in their composition are called hydroxides. Example: hydrochloric acid, HCl; hydroiodic acid, HI; hydromorphic acid, HBr. Okay. Next, classification based on the strength of acid. Almost all acids deoxidate in water and produce hydrogen ion to a lesser or greater extent. And the strength of an acid depends on the concentration of the hydrogen ions present in a solution. Greater the number of hydrogen ions present, greater is the strength of acid. However, some acids do not deoxidate to any appreciable extent in water, such as carbonic acid. Therefore, the acids will have a low concentration of hydrogen ions. Based on acids are classified as strong acid, weak acid. Strongest and weak acid. First, strong acid. An acid which dissociates completely or most completely in water is classified as a strong acid. Example: H plus plus H2O. It will give H3O plus because one H is there and mix with H2, two hydrogens. It will become H3. Examples: hydrochloric acid, sulfuric acid and nitric acid, etc. HCl. it will gives from H plus Cl minus, H plus Cl minus, and H2SO4. 2H plus SO4 minus. This is aquatic. And next, HNO3. H and O3. It will get from H plus NO3 minus. And next, weak acid. An acid which dissociates negligibility or mostly incomplete in water is classified as weak acid. Examples: acetic acid, formic acid, carbonic acid. CH3COOH. CH3COOH. It will get from CH3COO minus plus H plus. And another one, formic acid. H3COOH. H3 HC, it gains from CH3, HCOH, OH. It gains from HCOO minus plus H plus. And another one, H2CO3. It gains from two types, H plus plus HCO3 minus, or 2H plus plus CO2 3 minus. And next, classification based on the concentration of the acid. Concentration of an acid solution depends upon the percentage of the acid that is dissolved in water. Based on these acids are classified as concentrated acid, dilute acid. Okay. First, an acid that have a relatively high percentage of the acid dissolved in aqueous solution is classified as concentrated acid. Example concentrated hydrochloric acid, sulfuric acid, nitric acid, and acetic acid, etc. Next, dilute acid. An acid which has a relatively low percentage of the acid dissolved in aqueous solution is classified as a dilute acid. Example, dilute hydrochloric acid, sulfuric acid, nitric acid, and acetic acid, etc. Next, classification based on the basicity of the acid. First one, monobasic acid, and second one, dibasic acid, and tribasic acid. That's all. Oh, and base. Okay. A monobasic acid has one hydrogen ion, hence these acids combine with one hydrochloric group of a base to form salt and water. Since monobasic acid have only one hydrogen ion, they form only one kind of salt. Hydrochloric acid HCl, hydrochloric acid HI. Examples, hydrochloric acid means HCl, HI means hydronic ion, and HNO3 means nitric acid. Acetic acid. Mark wrong side amara. Ante? Okay. HNO3 means nitric acid, and CH3COOH means acetic acid. HOCl means hydrochlorous acid. HCOOH means formic acid. HBr means hydrochloric acid. And next, dibasic acid. When an acid can combine with two hydroxyl groups, it is known as dibasic acid. Such acids deactivate in two steps in water. First step, H2CO4 aquatic, H plus plus H plus 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 H HO4 minus. Okay, next HSO4 minus H plus plus H442 minus. Right? Next, 2 NaH plus H2Cl. And now 2 NaOH plus H2SO4. It will give Na2SO4 plus 2H2O. Liquid, aquatic, and aquatic. Since dibasic acid have 2 hydrogen ions, it can form 2 kinds of salt. That is the normal salt given above and a hydrogen salt. And now hydrogen salt now as given below. Now sodium hydroxide and sulfuric acid. It will give sodium hydrogen sulfate plus water. Water came from H2O. Hydrogen plus O2. Example: sulfuric acid H2SO4, sulfurous acid H2SO3, carbonic acid H2CO3, oxalic acid COOH2. And next, tribasic acid. The tribasic acids can combine with 3 hydraulic groups. This acid must have 3 replaceable hydrogen ions, such as and as such they can form 3 types of salt. Example: for phosphoric acid H3PO4 and phosphoric acid dissociatic in water and 3 steps. H3PO4 H plus H2PO4, and second one, this is the first one and second one, H2PO4 minus H3 plus HPO2 in the 4 minus, and third one HPO2 minus 4 minus, it gives H plus PO4 O3 4 minus. And next one, all of you do subscribe to our channel. Grand off. Sodium hydroxide plus phosphoric acid monosodium dihydrogen phosphate plus water. Next, gets to sodium hydrogen phosphoric acid, disodium ion monohydrogen phosphate plus water. Sodium hydrogen plus phosphoric acid plus trisodium phosphate plus water. 3NOH plus H3PO4. It gives Na3PO4 plus 3H2O. And next, okay, and we will discuss some points in the base also. Acid is completed. Totally acid was completed. We have totally discussed in acid, and now we will discuss some points in bases. We have completed 7 pages. Okay, not completed 7 pages, 6.5. Next I will take lacquer. Base. Similar to acids, bases also dissociate in water, but in place of H+. They produce hydraulic ion OH-. Thus a base in a compound which on dissolving in water else hydrochloric acid, hydrochloric ion, hydro as the only negative ions. The characteristic property of a base is due to the presence of these negative hydraulic ions. A base may be on an oxide or a hydroxide of a metal. If a base is soluble in water, it dissociates to form a metal ion and the only negative hydrochloric ion substances that combine with acids to form the salt and water are also called say pause the video and write the answer in the comment section. The answer is bases. Ammonium hydroxide is also a base. In water, it dissociates to form ammonium. Ammonium. Ion and a hydrochloric acid. NaOH. It is aquatic. It gives Na plus. Aquatic. Plus OH minus. It is also aquatic. And Na4OH. Aquatic. It gives Na4H plus OH minus. And now alkali. Base are completed? Oh, not completed. Okay, we will discuss in the next video.